Once again, welcome to my YouTube channel, Pearson and Excel International Maths. And in this video, I want to extend some explanation on the solids. And we have example 10 on page 149 of IGCSE asking us to calculate the volume of the volume and the surface area of the prism shown. First of all, you know that the volume is area of cross section, the area of cross section times the parallel sides or the height. Let me call it the height. The parallel sides, of course, you can see it's that one, and that one. And this particular region, which is, if I may shade that, of course, it is the uniform. This is the uniform cross-sectional face or area. So this cross-section, if you keep cutting along this line parallel to this line, you will continue to see the same shape, the same shape, the same shape, the same shape, the same shape. So that is why it's called uniform cross-sectional area. And therefore, it's just going to be, it's rectangular in shape and of course right angle triangle. So a half times base times 15, of course now times the parallel sides, which is 20. You are there with your volume, and of course this is by 2, 1 by 2, 4 times 15, 60, and 60 times 20 is 120 centimeter cubed. You get 60 times 20 is 1200 centimeter cubed, and that is it. Part B of that question, we are supposed to get the surface area. Of course, you can see the surface area is the total, which is the sigma, or rather, let me just introduce what is familiar with you, is the total area of all the faces added together. How many faces do we have? We have this rectangle. It has an identical face there. So two triangles, rather, not rectangles, two triangles. It has two triangles, and this is a half times 8 times 15 times 2. Of course, this is equals to 120, because 15 times 8 is simply 120. There is the bottom face, the bottom face, whose length is 20 and the wind is 8. There is the bottom, which is 8 times 20, giving us 160, centimeters squared. And then there is the face behind, 15 times 20, the face behind, which is just behind, 15 times 20. There is the face behind, which is 15 times 20, and I'm persuaded this is 300. And of course there is the slanting face that you can see, or luckily we are given this length. If we were not given this length, then we would have applied Pythagoras theorem. 8 squared plus 15 squared is equals to the hypotenuse squared, but luckily we have this length, and therefore it's called the slanting face, which is 17 times 20, which is 340. Add all this together, you get 340 plus 300 plus 160 plus 120, and you get something to do with 920 centimeters squared. 920 centimeter squared. And that is as far as example 10 is concerned. In the same video, I'm persuaded to explain example 11 because they use the same principle. In example 11, we are told to calculate the volume and total surface area of an open. These details are very important. Opened collar can that is a cylinder. Open collar can that is a cylinder. That is a cylinder with diameter 6 centimeters and height 11 centimeters. The first thing, we are supposed to calculate the volume and as well as the surface area. It's good to have a picture, or rather a diagram of what we are expected to have. And it is open on top, and this is cylindrical. It is open on top, and we have a diameter of 6 centimeters and a height of 11 centimeters. So volume is very easy. Volume is the area of the cross-sectional which is cylindrical, which is pi r squared times the pi times the height. Incidentally, the cross-sectional surface is circular and its area is pi r squared. This gives us 22 over 7 times the radius times 3 times 3. If the diameter is 6, the radius is 3, of course, times 11, which gives us something to do with let's talk about 22 times 9 times 11. Of course, everything divided by 7, and you get something to do with 311.1. This is 311, of course, to 3 significant figures, centimeter cubed, and that is the volume. The surface area, you have to go back to the question and an opened collar bottle, because the surface area is the total area of all the surfaces, and our bottle is open on top. So we are going to open it up, and since on top there is nothing, this part is open. This part is open. Even if we open it up along the perimeter, we are going to have something that looks like this, only retaining the bottom part, such that when you fold it up, this is now 3, and we said from here to here is the total perimeter or the circumference of the circle. So the surface area is the bottom plus the curved surface. There is no top. Please note that there is no top. Why? Because our can is open. And of course, along the length of the curved surface is the perimeter. We said that if you fold this length along the circumference, this end will reach here, and this end will reach here, and then it goes back to its position, which was originally the perimeter. So, and this height remains 11 centimeters. So what is the bottom? The bottom is circular, which means pi 3 squared, pi times 3 squared. And let's talk about that. Pi times 9, which is 9 pi, 28.27, which is 28.27 centimeters squared. What about now the curved surface? The curved surface, which is the perimeter, 2 pi r times height, 2 pi r times height, which is 11. Now we need to get to pi times 2 times 3 times 11. This is it. You get 66 pi, which is 207. This is 207.3. 0.34 or 35. So the total surface area is 207.3 plus 28.3, and you will always get it like 207.3 plus 28.3, and you'll get it like 235 total surface area, 2 circles plus curved surface, total surface area. Remember, it is open, by the way, it is just open, because example 11 talks about an opened collar bottle, and this, if it was an opened, then we are going to talk about 235.6 centimeter squared. 235.6 centimeter squared. Remember, the top was open. If the top was closed, just like the question suggests, because I've seen some correction, if the top was closed, then we are supposed to add another circle, which means plus 28.3, because top and the bottom was supposed to have the same area. If the top was closed, then we should add the area of the bottom. We should add the area of the bottom circle, meaning that it should be 235.6 plus 28.3 to give us plus 28.3 to give us 263.9 to give us 263.9 centimeter squared. Yes, please note that we have worked out example 11 with two scenarios: one, an open top, and two, when the collar bottle was closed at the bottom as well as at the top. This would be the surface area. The volume doesn't change, and that is it. All right, again, go to my YouTube channel, make sure that you subscribe and share widely, and let us move together. All right.